Okay, so let us begin the second part of this proposition. So in the second part, given that E is an equalizer of F and G and K is an isomorphism from E dash to E. So given that, so you have, see this diagram, E to A, this is E, and A to B. You have the morphisms F and G. So given that E is an equalizer of, E is an equalizer of F and G, and you have an isomorphism E dash to A, that is E dash to A, that is K. Okay, and K from E dash to E is an isomorphism. Is an isomorphism. Now, what is to be shown? To be shown that E composition K is from E dash to A. So our claim is that it is an isomorphism. So to show that E composition K from E dash to A is an equalizer of F and G, of F and G. Okay. So in the first place, E composition K, uh, now since this is an equalizer, so for any morphism E dash, since E is an equalizer, so for any morphism E dash here, you will get a unique morphism E bar from here to here, such that this triangle commutes. So since E is an equalizer, so there exists unique morphism E bar from E dash to E, such that uh, E composition E bar is E dash. This is given. Okay, so since E bar is unique, now see here, K is from E dash to E. So K inverse would be in the reverse direction because it's an isomorphism, so I will have its inverse. Okay, so then K inverse composition E bar would be unique because inverse of an isomorphism is unique, E bar is unique, so the composition would be unique. And so K inverse composition E bar is also unique. Okay, unique morphism. So then, so it is to be shown that it is an equalizer. So then this, so I have this now. Here, see this diagram. E dash to A. This is what? E composition K. E composition K. And here you have A to B, you have the pair of morphisms F and G. So first I should get that F composition E composition K should be same as G composition E composition K. So now F composition E composition K, this is equal to F composition E composition K. Now F composition E is same as G composition E because E is an equalizer. So it is G composition E composition K, and it is G composition E composition K. So the first thing is clear. Okay. So first condition of the fact that it is an equalizer is satisfied. Now second condition. Suppose I have an object here E dash, and I have a morphism from here to here, small E dash. Then I should get a unique morphism from here to here such that this triangle commutes. And I am already getting a unique morphism here. If you see this K inverse composition E dash, K inverse composition E dash is from E dash to A. Okay, so this morphism K inverse composition E dash E bar is unique, and it makes the diagram commute. If you see, if you compose these two, so now E composition K composition uh, K inverse composition E bar, it is E composition K composition K inverse composition E bar. Now K composition K inverse is identity, so it is, you are getting actually E composition E bar, and E composition E bar is actually E dash. Okay, so it is E dash. So you are getting a unique morphism which makes this triangle commute, and it shows that E composition K is an equalizer, which shows that E composition K is an equalizer. Okay, so equalizers are essentially unique. This we have shown. Next theorem is also important actually. If you So we want to prove a theorem which actually gives the relationship between epimorphisms. We have already seen that equalizers are monomorphisms, but next we will see that they are also epimorphisms in some special case. So see the proposition if e to a small e is an equalizer of pair of morphisms from a to b, say f and g. Okay, it's an equalizer. Then the following are equivalent. Then the following are equivalent. First, f is g. Second, e is an epimorphism. E is an epimorphism. Third, E is an isomorphism. E is an isomorphism. And fourth, identity on A is an equalizer of F and G. Identity on A is an equalizer of F and G. So these three things, these four things, they are equivalent. Okay. So let us first prove first implies second. So proof first implies second. Now suppose F is equal to G. Okay. Suppose F is equal to G. Suppose F equals G. Now you show that E is an epimorphism. Okay. So you are given that this E is an equalizer. So you have E to A to B, you have F and G. Okay. So since E is an equalizer, E is an equalizer. So F composition E equals G composition E. Okay. But then F is G implies F is G. Okay. And what does it show? It shows that E is an epimorphism, which shows that E is an epimorphism. Or in other words, you can say that the equalizer of same pair, same morphism is an epimorphism. Now, first implies 2. Now, second implies 3. By assuming that E is an epimorphism, you will show that it is an isomorphism. So, second implies third. So, given that E is an epimorphism, okay. So, given that E is an epimorphism, means E to A, E and A to B, I have pair of morphisms F and G such that F composition E equals G composition E implies F equal to G. So this is due to epimorphism. And this E is also an equalizer. Okay. So if you now see this diagram, now see the diagram. So you have here E, E to A, you have E, and here you have A to B, you have pair of morphisms F and G. Now what do I do here? I again take here A and take here to here I take identity on A. Now I am given that F is G. So this means F composition identity on A is same as G composition identity on A. And since this E is an equalizer, so I will get a unique morphism from A to E. Okay, say N. So there is a unique morphism. So there is a unique morphism and from and from A to E such that E composition N is identity. E composition N is identity on A. Also, if I take E composition and composition E, it is E composition and composition E. So it is identity on A composition E, which is E, which is also E composition identity on. Okay, so E composition and composition is E composition identity on E, and E is an equalizers, and equalizers are monomorphisms, so they are left cancellables. Now, since we have just seen that E is also a monomorphism, E is also a monomorphism. This this and composition E must be identity on E, implies and composition E must be identity on E. And what does it show? It shows that E is an isomorphism because I am getting a morphism in the reverse direction, and such that I am getting E composition N is identity on A and N composition E is identity on E, which shows that E is an isomorphism, which shows that E is an isomorphism. Okay, now 2 implies 3 is also true. Now 3 implies 4. In the 3 implies 4, if E is an isomorphism, I have to show that identity on A is an equalizer of F and G. Now 3 implies 4. So let E to A E be an isomorphism. Means what? Means there exists N from A to E such that E composition N is identity on A and N composition E is identity on E. So I will show that identity on A is a is an equalizer of F and G. So here you take, now see this diagram. Now consider the diagram. Consider diagram. Here you have A to A identity on A and A to B. You have pair of morphisms F and G. So I have to show that this is actually an equalizer. So identity on A is an equalizer. This is our claim. Now first I will have to show that F composition identity on A should be same as F composition identity on this G composition identity on A. Okay. Now F composition identity on A is F composition here, see, E composition N. F composition E composition N, which is F composition E composition N. But F composition is same as G composition E because E is an equalizer, so which is equal to G composition E composition N, which is G composition E composition N. Okay, so it is G composition identity on A. So first thing is true. Now let you have an object here A dash, and you have say E dash from here to here a morphism such that F composition E dash is G composition E dash. So let A dash to A E dash such that F composition A dash is G composition E dash. So I must find from A to A dash some morphism, unique morphism such that this triangle commutes. Okay, A dash to A. Now I will take the same morphism here, this A, E dash. I have this morphism E dash. Okay, I will show that this is unique and this diagram commutes. Diagram of course commutes because so clearly at this identity on A composition E dash is E dash. So the diagram commutes. So the triangle commutes. So the triangle commutes. And this is unique. This is also unique. Suppose I have another morphism from here to here, say E bar, such that this triangle commutes. So let E bar from A dash to A such that identity on A composition E bar is E dash, but then it would imply that E bar is E dash. Okay, so E dash is unique. So E dash is unique. Okay, which shows that this is an equalizer. So 3 implies 4 is also true. And 4 implies 1 is clear. 4 implies 1 is, why it is clear? Because I have to show that f is equal to g. Now here I am getting, by the fact that this is an equalizer, I will get that F composition identity on A equals G composition identity on A. This I will get, but this is F. This will get F equal to G. So this is actually 4 implies 1. Okay, so all the 4 statements, they are equivalent. Okay, so I will leave an exercise for you and I will end this lecture with this exercise. Exercise: if A to B, B to A, say this A to B is G and it is F, say this is equal to A to A identity on A. That is, actually we are assuming that F composition G is identity on A. Then prove that, and then show that G is an equalizer of G composition F and identity on B. Then show that G is an equalizer of G and identity on B. Okay, so this is an exercise. You do this. So I will, if you have any question, then you can ask. Otherwise, I will stop this. Any question? Okay, so let us stop this lecture. We will see in the next lecture.